This is the solution to question 4 for HCAHPS 725 Statistical Process Improvement. The solution was provided by Dr. Maria Urio. The problem requires you to download data from Hospital Compare. You have to use as many years as available. When you unzip the files, you want to select the file called HCAHPS-Hospital. This is the file for satisfaction surveys. Within these files, you want to select the HCAHPS measure ID of HCOMP6 linear score. This is the linear mean of ratings of surveyed patients. It is a value between 0 and 100%, with 100% indicating most satisfied patients. You are then to compare the performance of Sibley Hospital to the hospitals in DC, and you've been given the different provider IDs. And then the question is, are the satisfaction levels in Sibley better than those of the other hospitals in DC? This slide shows the zipped files that were downloaded from the Hospital Compare website. And after each download, the files were unzipped and saved in the corresponding folder. Within each resulting folder, you need to look for the HCAHPS Hospital file. And in this slide, we're showing you the year 2015, 12, 10, and the resulting HCAHPS Hospital that is highlighted on the left. And we go through this process for the remaining years from each folder and extract those files and name them accordingly. Since we're going to be using an X-bar chart, 3 assumptions have to be met. And the first one is that the satisfaction rating is a continuous scale, and that the patients are independent of each other, and that the data has a normal distribution. In this situation here, the histogram displays the distribution of the satisfaction rating. And you can see it's kind of normal, and the fact that the grand average is 82.04, which is right in the middle of the displayed histogram. And the process for determining or creating this histogram will be shown later on in the presentation. Open Python and import the following libraries: pandas, numpy, math, and matplotlib. In addition, we're going to be reading 5 files representing the years 2014 all the way to 2018. And notice that the files are CSV, so you need to use the pd.read_CSV. Once you've imported the files into the associated data frames, you need to at least look inside one of those data frames to see what's going on. So why do we use engine equals Python? Without using engine equals Python, at least you should try it, you'll get a Unicode decode error message, meaning that your data could not be imported. And by using the engine equals Python, you're preventing the occurrence of this Unicode decode error, and then you'll be able to read your files into pandas without any issue. This slide displays a snapshot of one of the data frames. We need to check the column names in the various data frames. You'll notice that in 2018 that some of the column names changed. This slide shows you what the column name changes were. So 2017 all the way to 2015, the column names are the same. But in 2018, what changed was the facility and facility name instead of using provider ID and hospital name. And also the measure start date and the measure end date changed to start date and end date. And again, all these are critical attributes that you need to use in your calculation going forward. Each of the original files have about 22 columns. We don't need all those columns in our analysis. So in this slide, I'm showing you how to minimize the number of columns and select only those that you need. And we're creating new data frames and naming them by the year. So we're using provider ID, hospital name, HCAHPS measure ID, HCAHPS linear means value, measure start date, and measure end date. And for 2018, that changed to facility ID, facility name, start date, and end date. And furthermore, we're saying we only want within the measure ID column the measure that says HCOMP6 linear score. So we're narrowing our columns and narrowing our rows so that we have a compact data set. You should check all your data frames from the previous step, but on this slide I'm just showing you the data frame from 2018 that was filtered. And now, based on our limitations and specifications in terms of the columns and the rows, what we have here is a data set that shows that the HCAHPS measure ID is only the HCOMP6 linear score. We have the mean value, the start date, end date, the facility name, facility ID. But in the mean value column, you can see that not all the values are numeric, that we have an entry in there that is clearly string. We need to determine the data type from each of the data frames. For each of the 5 years, the data frames indicate that the HCAHPS linear mean value is of object data type. This needs to be converted to a float data type. In this slide, we're checking for non-numeric data within the HCAHPS linear mean value column. We are doing that by using the data 2018 filtered and then the HCAHPS linear mean value dot as type float in quotes. And then you'll get a traceback feedback message that includes a value error, and it shows you that it could not convert the not available string to a float. So I'm not showing the whole error message. You have to scroll all the way down to the end of the error message, and you'll see the message value error, could not convert string to float, not available. We're going to convert the not available entry with 0 and then convert the HCAHPS linear mean value column to a float. So it's going to be occurring in 2 steps for each data frame for each given year. We're checking how the column has been updated. And in this slide, I'm just showing data from 2014. And you can see that the not available entry have been changed to 0. And then the data type is a float. We are looking at the updated 2018 data frame by using the dot head bracket function. And we can see that the HCAHPS linear mean value now has numeric values and that the not available has been replaced by 0. So this is just another view of the data frame from the previous step. In this slide, we're going to be applying conditions to the data frame. We want to narrow down our data to only have information for Sibley and all the other different DC hospitals. We are using a variable called PIDS, and that variable contains all the hospitals we're interested in. And we use that PIDS variable in the code by calling it towards the end here. You can see dot is in bracket PIDS. This slide shows the output for the conditions that you've applied. We are determining the number of rows and columns in the new data frame. In this slide, we're going to be calculating the average satisfaction at Sibley Hospital. We create a variable called HOSP, and in that variable, we're going to be putting the Sibley Memorial Hospital name. And then we're going to be looking for a data frame that will only have the hospital name of Sibley inside the hospital name column. And then after you get that result, we're going to be calculating the average satisfaction for each given year by using the mean function. We're now going to be calculating the average satisfaction in other DC hospitals. I'm going to use the 2014 DC data frame. And we're using, for example, the data underscore 2014 filtered to, and that data set has all the hospitals in DC as well as the Sibley Memorial Hospital. So we need to filter out the Sibley Memorial Hospital from that data set. And we do that by using this exclamation equal sign. So we say exclamation equal sign Sibley Memorial Hospital. By doing so, we're excluding Sibley from that data set. So once we do that, then we're going to be able to calculate the average satisfaction for that resulting new data frame by calculating the mean of the HCAHPS Linear Mean Value column. In this slide, we're creating a data frame containing the DC and Sibley Hospital data from all 5 years in order to be able to determine the grand average. The formula for obtaining the grand average as well as the standard deviation for the DC and Sibley hospitals are shown on this slide. We can see that the grand average is 82.04 and the standard deviation is 5.65. We are now creating a data frame containing DC satisfaction data from all 5 years. We need to check for normal distribution, and this slide shows you how to do so. We begin by using again the data 2014 filtered to, and we're going to be working with the HCAHPS linear mean value for all the 5 years. And essentially what we're doing here is kind of like stacking the data on top of each other, if you can think of that. And so we are using the .append function to do that. And towards the end, you've appended all your files together. So you take the last appended file and you plot it. And in here, we're using the .plot.hist function. This slide shows the average satisfaction scores for the DC hospitals across 5 years. And on the right, we have the corresponding standard deviation values. We are now counting the number of hospitals in DC across the different 5 years. And then the z-stat value that we'll be using is 1.96. We are creating a data frame that will be used for holding values that can be used for the calculation of the upper and lower control limits. We're using more descriptive names for the column names, and this is how you can rename your column names. This step shows how to calculate the UCL and LCL values. The code for plotting the X-bar chart is shown on this slide. This is the chart generated showing satisfaction rating between Sibley versus DC competitors.